Okay, implement my A2I function converts 32-bit signed integer. The A2I as follows. Like I said, trimming is cheating. So we want to, I guess we'll make like a finite state machine. I think these are pretty helpful. So we'll say let state equals something. I'll create a type called state, and we'll say beginning, or yeah, beginning. And we'll say index equals 0, and we'll do while index is less than s, and then we'll say if state equals beginning. Oh, we're not doing TypeScript, are we? Basically, if we're in the beginning, then if state, or if equals s sub index, so if character equals the space character, then we'll just do index plus plus. Else we'll say state equals, I'm going to create constants at least. Const state sign, what is called spaces then? Sign or number equals sign or number. Sign or number. And I'll say else if state equals sign or number. So I'll say const state, sorry, sign equals 1. And then so if character equals negative, then we'll say state equals state number. Else, and then we hit the index plus plus. Otherwise, I guess we always do this. It's just the question becomes, and then we also have to have an output equals 0, and we'll return the output. But these are multiple lines. So if we're in the sign or number state, then we're gonna basically instantly switch this to the state. We should call this state. We're gonna instantly switch to the number state, but if we see a negative character, then the sign becomes negative and we increment. Otherwise, we stay on the same thing because we want to make sure that we're processing the number. So we have state number. Now, we could parse it, but I think parsing is cheating. I think it's better to say const 0 equals dot char code at 0. I believe 0 is the first number in the sequence of numbers in terms of ASCII. Sign this conversion, read the integer by skipping leading zeros. Returning a non-digit character is considered end. Or the end of a string is reached if digits were read. If no digits were read, the result is 0. Skipping leading zeros until non-digit character is counted. Interesting. Okay. So let's say const value equals character dot char code at 0, and then we'll say minus 0. And so if value is, we're gonna do 0 is less than equal to value, and value is less than equal to 9, then we will do output plus equals output times 10 plus value. Else increment index. Else we return the output early. Basically, we want to see if we're getting a number 0 to 9. If we do, then that's the next digit in the number, so we need to like multiply our current number by 10, basically pushing all the digits over by 1, and then add that value as a new ones place. So we'll run it. Char code. Oh my gosh. Didn't put a dot length there, which meant who knows. Runs forever, I guess. Okay, so we didn't get the negative. So for some reason we're not going into here. So let's put a console log, and we'll do state character sign index. See if we ever enter this. If we do, it's sign or number. The character is the minus sign. Is it like a different minus sign? Oh my gosh, it's not. I'm just not multiplying it out. Alright, we'll run it. Okay, so this is the way that an interviewer would expect you to write this algorithm as a finite state machine. You could probably do it with one less state, but I think it'd be very hard, to be honest. Basically, we start out in this whitespace state where we're just skipping all white spaces. Every time we see a white space, we skip. If we don't see a white space, then we switch to a different state, which is looking, do we see a sign or a number? Basically, there's only one chance to see a sign. Only one chance to see a sign. If we do see the sign, then yeah, we're gonna increment and say that the sign is negative. Otherwise, we don't increment. We stay there because it could be a number that we need to read. And so we switch this number state. We're basically determining a number based on its char code. So in like ASCII characters, char codes, in terms of ordering, there's like a whole bunch of numbers before the numbers, or there's a whole bunch of characters before the numbers, a whole bunch of characters after the numbers, but the numbers go from 0 to 9. So we're basically taking the char code of 0, which is like, I don't know, 60, let's say. That would be 60. And then we take the char code of whatever thing we are looking at, which could be like 69, 68, 67, 66. And we basically take 66 minus 60 and we get 6 for the value. 6 is between 0 and 9. So we apply that to our output. If we find something that's not a character, then we opt out early and return the output times sign. We could break. I don't like breaks. I think breaks are cheating. So we'll submit it and see how we did. Something that I didn't mention is that there is another way to potentially write this code, but at any rate, it doesn't even seem like we have a valid output. So I guess there's an edge case that we missed, because they gave this as input, and our output was this, but they expected a totally different number. So we gotta go back to the description and see. Okay, so the integer is out of bounds, and then it needs to remain in bounds. Okay, so we just missed an edge case constraint here. We can say const bound equals 2 to the power of 31. And I don't want to write the same code twice, so I will be breaking out of this. I know I said I was cheating, but yeah, it's just better to write code one time. Let's see. So what we're going to do is a math.max and a math.min. So we want bound and bound. I think this is negative bound. And this is -1. So we're just looking at this. That's between -2 to the 31 and 2 to the 31 minus 1. So this is 2 to the 31 minus 1, we're doing the min on that because if the number goes beyond that, we want to take the smaller value. And similarly, this is just -2 to the 31. We're using the max because if the number goes below this, we want to use the bigger of the two numbers. So let's submit it. Okay. I did not know that there was a plus variant. So important to read all of the requirements. In this case, we just increment index. So many test cases. Okay, so I know why this isn't the fastest. It's because we hard-coded, we coded it all out. There's nothing wrong with doing a finite state machine. This is the answer that an interviewer would be looking for. I can imagine that a faster solution, if we really wanted it, would be s.trim, even trim start, new number. Actually, we can even do parse int. Null is not value for expected return type integer. That's interesting. Do we even need to? I'm curious if we even need to trim here. Try a new number. I'm just trying to see how flexible the TypeScript. 42 is not valid value for the expected return type integer. What? That's curious. I thought that this would have been like fairly straightforward. What does parsing do? So in this case, it should return 0. Okay. Unknown network error, please try reloading. Right? Now, I think this will likely get a better runtime. Obviously, it's less code, and most of the code that is running in the. Actually, there's one more thing to do. I imagine this will run in 0 milliseconds, but wow. Interesting. Okay. I mean, yeah, if we wanted to do it in less lines of code, this is a way to do it, but I'm curious how you do it even faster. Oh, well. I got lucky. My finite state machine eventually ran in 0 milliseconds. Perfect. Okay, so let's look at the best solution. Oh, wow. Oh, okay. Alright, so let's try to gather an understanding. So they just trim. They don't even try to process spaces like we did. And then after they trim, if there's nothing to process, yeah, it's fine. It should automatically be handled by everything else. Depending on how you write the code. But yeah, they don't do a finite state machine. They just kind of keep track of the state by through just brute force of how the code is written. Essentially, they just this is the new state. After this they process all the the spaces. After this they process the sign. This part is interesting. They see if the number is in range. If it's not, then they break. Which we did kind of do that too, but we didn't compare the characters against each other. We compared the resulting number. Here they actually put a plus sign in front of what would be a string, which JavaScript has an interesting way of handling. If it sees a plus sign in front of something, it's going to be like, that's a number, and it'll convert it. So if this is like the string 0 through 9, it'll convert it to 0, 1, 2, 3, 4, 5, whatever. This is interesting. They're basically like... What? What's this? Wait, what is this doing? I thought that I knew what they were doing for a second, but I don't. If the result is greater than int max divided by 10, Lord, why? I think that they're just doing this one step earlier. If they just... It's interesting that they have this in the loop to kind of opt out early. I think that's a cool idea, but they could have done it on this line and not done the division by 10. They're basically like predicting that when this line of code runs, it'll be bigger or less than these values, but they could have just did this after this line, avoided the division by 10. Digit greater than 7. What is digit? This is very random. Is it 7, 8, 9? I mean, it's probably essential for their... It's probably because of a division by 10 issue or something. No, it's not division by 10 issue. It's probably because 7, 8, or 9 has the ability to... are the only ones that have the ability to go over in this case. If sign equals 1. Yeah, I mean, they just overcomplicated this part, but that's okay. Okay, so they manually processed their white spaces separately, and then they processed their sign, and that determines where I is. So they did a pseudo finite state machine as well. They had the same logic. What? Why would they do the same logic? They even know about the digit greater than 7. That's crazy. The other problem is they're doing this every iteration. Every single time they do this. So this makes the algorithm slower. It's better to just, it has the potential to opt out early. Sure. But you're running it a few times before the fact. And maybe there's worst case scenario for very large numbers. Maybe there's the chance that it does get very large. And there's just no point of running the algorithm anymore. But it's just like, just do it after the equals result. Like divide 10, digit greater than 7. It's just like, it's really hard to read. I'm curious if anyone doesn't do it with this approach, so I'm gonna click through and see. Wow, everyone actually. Oh, this one looks interesting. Because they have a regex. This regex is like, at the beginning, there's a plus or a minus, maybe. Then there's a bunch of numbers, and then there's a decimal, and then there's more numbers, maybe, which is non-capturing. This is really hard to read. Oh, well, they just wrote it out. Wow. Does anyone do like the naive solution? Zero more spaces, plus or minus, digits. If not a match, return 0. Wow. Convert the number to a string. Wow. They use a capturing group. Look at the captured group. Parse it to a number. So they use regex, and it's like one of the slower solutions for sure. Okay. I mean, nobody really. I'm surprised. I thought people would have done it this way. Like, this is 2 lines of code. I mean, yeah, 2 lines of code. And no one really did it this way. But this is what an interviewer is looking for, anyway.